Hi, could Eric please sign out?
Hey guys, while everyone's waiting, you guys could fill out the attendance form. Thanks.
Hi everyone. Alright everyone, welcome to the Transfer today from Sumobots 2022 CAD workshop. So in this workshop we're gonna go through CAD and basic coding by do, and I'm gonna go through 3D printing. There will be food afterwards, which is going to be Subways. And yeah, so make sure that you have signed the out form from your QR code. Yeah. Could all the mentors for today you know, stand out and introduce yourselves? I think let's just move on to yeah. There's a CAD section. Start having the CAD section up.
Alright, welcome guys. My name is Kundu and I'll be going through the CAD and the laser cutting for today's workshop. So essentially CAD is just us using computers to design components. And this is just two photos of what engineers used to do. So before CAD, engineers would like draw all their drawings by hand, and you know, they create amazing things. And we'll be doing something similar to that, I suppose. But we'll be going through some SolidWorks today. And we're going to be making in a 3D assembly of a shaft key, which is just that thing over there, and a keyhole for that shaft key. Yeah.
What was computer aided design again?
Yeah, so computer aided design is just us using computers to design engineering components instead of us having to like draw them by hand. And then, you know, an extension of that is us being able to make full engineering products that have multiple complex components all within one small thing. So instead of us having to draw like 100 pages of engineering drawings for one assembly, I have one.
Can everyone be quiet? The workshop has just started. Please be quiet.
Before we start, does everyone have SolidWorks installed or a similar CAD product? Okay, I'll just quickly go through how we can get SolidWorks using My Access. So if you just go to My Access on Google and just log in real quick. Does everyone have access to My Access, by the way? If everyone could just open up SolidWorks 2021 on y-axis real quick, we'll just run it through the all right, everyone, let's start. We'll be starting with some 2D sketching. So, yeah.
Quick poll, is it like AutoCAD or SolidWorks?
SolidWorks, preferably.
Can use AutoCAD a lot, it doesn't really matter. And Fusion, Fusion's good.
The ideas we go through today's lecture will be transferable between most CAD softwares. So if you're proficient with SolidWorks, chances are you can transfer those skills to Fusion 360 or AutoCAD Inventor. So it's a good skill to have. Alright, I think, is everyone good? Does anyone not have SolidWorks open right now? Okay, I'll just get started. So, 2D sketching. So essentially in SolidWorks, you're creating every component from a 2D sketch and then converting that to a 3D component. So what you want to do is, when you're starting a SolidWorks sketch, if you just click the sketch button in the sketch tab, you just select one of the axes to start sketching on. So in this example, I chose the top plane to start sketching on. And if you just click on it, you'll be given a working plane. So once we've got a sketch plane to work on, you can create any shape you want. So in our example for the key, I'm going to start doing a rectangle, center rectangle on the origin. So if I just pull it up on
What's the white?
Does anyone need a refresher on what we just did? Like, is anyone lost? space. And now what we can do from this rectangular sketch is draw more sketches on top of it. Hey guys, it's not. So what we can do with this rectangular sketch is draw a circle on each side. So what I selected was the tangent arc circle from this little tab there, and I started drawing from that corner to that corner. So if I just show you guys real quick. I just take the tangent arc circle, click on one corner, and then click on the other corner, and it will make that dimension there. So we have a circle now. And if I just do the same thing on the other side, I'll get the base sketch for our key. So an issue you guys might be, oh, I forgot to mention, you guys can make the key any dimension you want, doesn't really matter. Just as long as you remember what the dimensions you use for the keyboard, just so we can make the keyboard the same size as the key.
Yeah, more or less. Some of them are sort of the rest of them. You want to check it, like, do you want to ask?
Guys, it's not. So you'll probably notice that the two circles aren't filled in yet. And that's because in SolidWorks, it requires a single line essentially to be considered one object. So the issue is SolidWorks doesn't realize that these semicircles are supposed to be part of one sketch. So what we want to do is click trim entities and just remove that line and that line, and it'll fill in. So the idea with SolidWorks, it's a little funky. SolidWorks requires closed bounds to be considered a shape. So once we've done that, we can exit the sketch, and now we have this shape in SolidWorks. Has everyone gone to this stage? Hey guys, it's not. Is anyone not at this stage yet? Does anyone need extra help? If anyone hasn't got to this stage yet, please put your hand up, because we kind of need this base sketch. Alright, that's awesome. So now that we've gotten our 2D sketch, we can move on to 3D modeling. So essentially, we're going to take that 2D sketch and just extrude it upwards. So if you go to the 3D modeling tab, so once we've finished our sketch, if you go to features and then hit extruded boss base, you can click on the sketch and extrude it by however millimeters you want. So just for the sake of this example, I'm going to extrude this up by 40 millimeters. And then if I just hit the tick, it will make a 3D object.
I am the Sumobots.
So now that we have this 3D model, we're going to be using some more SolidWorks features to make it look a little prettier and to have like a little bit more functional design. So we're going to be using the chamfer feature. And what the chamfer feature does is just, it takes a sharp edge of an object and makes a slope line. So you're removing your sharp edge. And the way we do that is just to go into features again, click the little arrow under fillet, and then click chamfer. Now once you've selected your chamfer operation, you just click on any curve you want to get chamfered. Hey guys, listen up. So now we've selected this edge to chamfer, and if I just click this right now, it's going to fail. Oh, it's not going to fail. So this chamfer is a little too big. So I'm just going to change the chamfer depth to around 2 mils. And just hit OK. And now we have a chamfer on our key. And now we just have that 45-degree slope on that sharp edge. It's no longer sharp yet.
We need him, bro. I'm like, hey, did you come to the again? We're gonna do this. We're gonna do this. What if I put in my application? Before your church today, we went to your barbecue. Some Sumobots making some fish. They're gonna say no. Yeah, that's why my bad. Yeah. You get no experience. You get
Alright guys, now that we've created our key, we're gonna create a place for that key to fit inside. So I just want you guys to have a go at creating that box. And all you have to do is just put the key and make sure the key fits inside that hole. So what you can do is you can remember the dimensions you put in for the key and make that the internal dimensions of the keyhole. And then just make the keyhole itself however thick you want. But just as a clue, this should just be one sketch and one extrusion. So I'll give you guys like 10 minutes and then we'll see how it goes. Sorry guys, for the key shaft, just make that into a new part. So what we're gonna do at the very end is make the key shaft and the keyhole together. So make that new component its own part.
Make a square, cross extrude it, and then make a square inside, then cut extrude it.
Well, you can just make 2 squares and just
Oh, yeah.
But then again, I don't know if you want to have
Guys, just make sure you save the first file. You might lose it because of Citrix.
Wait. Can I name my email Ruben? Okay. I said I'm going to Arya University 7. How's that? Yes. Because we need.
Alright, I'll just quickly go through how I would make this part in SolidWorks really quickly, just so you guys get an idea of like what you might be doing.
Oh my god, stop spoiling everything. Oh, very good choice. It's a very good movie.
Alright, so hey guys, what's up? So for the keyhole, hey guys. So for the keyhole I made, all I did was just on my, if you just have a look at my sketch, it's just two squares on top of each other. And then when you go into the boss extrude, it will automatically detect that I'm trying to find the area between those two rectangles, squares, just that area, and it will create a keyhole like that.
Jay. Jay.
And I'll just quickly go through how you do 3D assemblies. So it might be useful for your Sumobots for you to create multiple components in SolidWorks, just to simulate how you would set out your components in the real robot. So once we have our components, and we've saved both of them, we can create a new part, a new assembly. So what differs part and assembly is that in assembly you're combining multiple parts together. So when you guys open up your assembly, you might already just get the begin assembly tab, and it will show you all the components that you have saved on your local device. So what I'm going to do is I'm going to pull part 2, which is my keyhole, and then I'm also going to insert part 1, just like that. So now we have the keyhole and the key itself all in one assembly. Does anyone need me to go through that again? Yeah.
Yeah.
Alright. Let's go through that again. So when you have both of your parts saved, just go to File and hit New, and that will bring you this tab. From that, we can select the Assembly tab, and it'll create a new assembly file. And if you guys so once we're in the assembly file, you can just click the assembly tab and hit insert components. And that'll open up your Windows Explorer and just look for where your files are located. So the two files I want are part 1 and part 2. So I'm going to shift select both of them so I can open them together. I'm just going to insert the keyhole into here. Alright, so now I have both my parts in my assembly file. And what we're gonna do is we're going to make these two components to each other so they look like they're reconciled and they're fully constrained. So the easiest way to do this is just to hit the Make tab. And we're going to select that top surface of the key into that internal surface on the keyhole. And now if I just try and move this around, it's always going to be constrained to that surface. It will never move in that direction. And I'm going to do another make on this surface and that surface. And the key is going to be inside the keyhole. It's going to be constrained to that surface. So that's how you would create an assembly in SolidWorks. And the idea is for your Sumobots, you'd probably be designing your chassis in SolidWorks and then modeling whatever dimensions you need to so you can figure out which components need to go where. Does anyone have any questions on SolidWorks and remodeling assemblies? Guys, put your hands up if you have any questions regarding SolidWorks, because the mentor will come and help you. Alright, if no one has any questions, we'll move on to laser cutting. Alright guys, I'm going to move on to laser cutting. So with laser cutting, hey guys, listen up. Everyone. Alright, so the laser cutting process is fairly simple. The idea is you're just creating a 2D vector or like a 2D DXF file. You're creating whatever design you want, and then you're going to go into the lab and get that design onto the University of Laser Cutters. So the design process is you just creating a file, whatever design you want, whatever material you want, and whatever size you draw up. You'll change the layer types of each line to the defined laser cutting machine's layers. So just to give you context for that, what that means. The laser cutter has certain colors it defines as its cutting type. So if the laser cutter sees a line that's completely black, it'll realize that it's going to be a normal cut. It's going to start engraving as a close shape. If it's light blue, hey everyone, listen up. And basically the laser cutters at the uni, just needs a color from your drawing to define what it's going to do. And red just means it's going to cut. So the university has the Speedy 400 laser cutters. So if you just go down to the Kirby Makerspace, that's what the two machines are at the back. And they can just laser cut most material speeds. I won't really go through it, but the idea for you when you're laser cutting is you're gonna create some sort of 2D sketch. Everyone listen. You're gonna create a 2D sketch, and then you're gonna save it as a DXF file. And a DXF file is just a format for a file type. It's a vector type. So essentially, every single line on that file is defined as a vector. So and the laser cutting process at the uni, once you have your DXF file, you'll load that onto Rhino. So Rhino is just a program that it's a type of CAD tool that the university uses. And what you can do is once you load the DXF file onto Rhino, you can change the layer colors that are required for the cutting. So if we go back to this slide, say you wanted to cut a rectangle, a square of this shape, you just change the DXF file's line colors to red, and the laser color will recognize that you're just doing a cut. Similarly, if you were to do this shape, but you want it to be a light score, you just change all the layers on that DXF, on that drawing to light blue, and it will do a light score on the plywood. If you guys get your laser cutting badge at the university, you will learn every single detail. They'll just go through the whole process with you in detail. It's a little complex for the workshop, so you learn every single detail if you get the laser cutting. Does anyone have any questions regarding laser cutting? The makerspace staff are really nice. So if you have any questions for laser cutting, just go and ask them, and they'll give you all the help you need. Does anyone have any questions for laser cutting?
Can I show you something?
So in Fusion, you would go to the surface, press P to project the surface onto a sketch, and then save that sketch to 2D. The sketch will be 2D. Yeah, create a sketch on the surface, right? Press P to project the surface, and you can get a 2D projection. But you can't just pull it. Yeah, and then you also have to manually do it on as well. I know that's an app. That's not a plugin that can cover it to just different models where you have the cross sections. The layers of the cross sections, right? Like a dinosaur, very small cross sections. Yeah, you can do that.
If you guys want to get a DXF file of your pod, all you have to do is when you go into the pod itself, you can just select the face and then right click and convert export as a DXF. So what it will do is it will take that face and then convert the face as a DXF file. If we just save that as a DXF. And then just click the tick.
My 200 meters sprint is actually 25.5. I got my 4-meter on. Actually 2 hours. 200
If no one has any questions about laser cutting, we'll move on to 3D printing.
Greetings, gamers. So, laser cutting. Great process, can 100% recommend. So, to laser cut, we have basically three main steps. Sorry. Yeah, basically three main steps. Once we have the 3D model that we made in SolidWorks or Fusion or whatever you want to make it in, we have to go through three main steps, which is we have to convert it to an STL or like any other file format that a slicer can understand. So an STL file is like basically like a collection of vertices which make up triangles, and that's the file format that a slicing program can understand. A printer cannot understand the file yet because 3D printers can only read G-code, which is like a collection of printer versions. The second part is we need to slice a model using a slicer such as Cura or process slicer. Those are the two main popular ones. In this case, we'll be using Cura. What the slicer does is it grabs the 3D model, right, and then converts it into a bunch of printer movements and just very basic steps that a printer can understand. And in the slicer, there are lots of options that we can choose, which I will go through afterwards. And that will determine how your print turns out in the end. And yeah, in the third part, you just basically just print it. So, design rules of 3D printing. We just went through like a bunch of CAD stuff just now, and that's all good, but like when we actually print, right, we have to take some of these things into account. This page is like a good, gives a good understanding of like what you actually need to do, but there are some things that are not exactly true of it. So, a support is like a feature, like an overhang is like a feature where when you print something, you go up and then you go basically horizontally out. That is very hard to print because in this planet we have this thing called gravity, and when you extrude, right, all the filament basically just drops down. So it's not ideal if you print at like a 90-degree overhang, but we can get away with some sort of overhang if it's like at an angle. So every layer builds up, it will build up more and more out. So the usual rule of thumb is like 45 degrees, but modern 3D printers can usually get away with 60 or even 75 degrees, which is what I got away with last time. 75 degrees, it comes out pretty well, even at this high angles, if you have adequate cooling. This is determined by the material you printed and the temperature, and I will go through that in a bit. Another rule is that when you have connecting parts, when you're fitting in a part to another, just like as we did in the key and the keyhole, right? Some of you might have done the dimensions to be exactly the same. When you have, let's say, 20 by 20 millimeters for the key and 20 by 20 millimeters for the keyhole. When you're actually printing, you wouldn't want to do that because it just wouldn't fit in properly. Usually, you want to have the gap, right? It says 0.5 there, but you can ignore that. Usually, you want the difference in size to be 0.2 mils on each side. So if it's like a round peg into a round hole, there'll be a 0.2 millimeter difference in radius or 0.4 millimeter difference in diameter. You can even get away with 0.3 mils difference in diameter, probably, but so that will make it about like 0.15. So yeah, with those tolerances, it will get you a pretty good fit, but it's printer dependent. So if you have a question, say again. Horizontal bridges. Oh yeah, I should go through that. So you know how I went through about overhangs where basically you're just printing on the air, right? Bridges are like that, but kind of different. Imagine you have like two vertical struts that you're printing up, and after a certain level, let's say you have each support. Like imagine like there are the supports of a bridge. And each one's about like 1 centimeter tall, and then there's a gap between them, let's say 2 centimeters, and then you want to bridge filaments over it. Usually, if you're printing an overhang, it's hard to get away with it. But if you're making a bridge, right, you can actually get away with quite long bridges. Last night, I actually did manage to get like a 140 millimeter bridge, which is like quite long, and usually you wouldn't do that. But if you have a good printer, you can get away with it. Big flex. Yeah. So what happens is that when you extrude the filament from one point to another point, right, the printhead kind of pulls the filament along, so it stays hot like you're pulling on a rope. And when it cools and dries, right, it shrinks a bit, so it further pulls them together. So bridging can allow you to get away with quite a bit of a distance compared to just lens. So I hope that answers the question. And small features, you have to keep that in mind because especially the features get too tall. Let's say you need something that's really tall and skinny. When the printer bed moves or when the printer moves, it can actually dock on the really skinny features and shake down, and it will produce a bad print. So you kind of have to make sure that the features are.
Hey guys, can we listen up?
Yep, you just have to make sure the features are not too tall and skinny. Otherwise, I have an example, but I can't really show it to you now. But that will create issues with the tall and skinny parts flexing when the printer goes over. But that's basically it. You don't have to worry about escape holes because that's like a thing for SLS printing or SLF, and we will be sticking with like the usual FDM style printing, which is like straight material through the hot and we should. Yes. This is the Mobius palette. It's one of my greatest creations. Enjoy. So, when we want to convert a 3D print, convert like a file that we make, like a 3D model that we make into something that can be understood by a slicer. Usually, CAD programs store files in proprietary formats, such as SolidWorks. You have the SOD PRG file. We can't really use that for a slicer. We have to convert it to STL. In Fusion, you would click on the left side, you would have all the bodies. Click on bodies, right click, save as mesh, and then in mesh, choose save as STL, refine the high, and up. Make sure you don't, make sure you uncheck set 3D utility. In SolidWorks, you would go file, save as, and then save as part STL, and it will automatically do it for you. Save it somewhere and then we can move on to the next step. Yeah. So next step is we have, as I said before, we have to slice that 3D model part into G-code, which basically the machine code that tells the printer at what time go to exactly where, when, and how much movement. Because the 3D printer cannot understand like a solid model; it can only understand basically like a text file that describes the exact movement of the vectors. In the slicing program, we can change many settings, which is what I'll go through in a bit. And the settings can determine how the print will turn out. For example, we can choose to enable or disable support, or change the temperature, and so on. Yeah, so this is some important slicing settings that we should all keep in mind. So, first of all, temperature. Usually, when we print PLA, which is one of the most common materials that we print with, you would want to go about, like, say, 200 degrees for the hot end, and also the print rate to be at around 60 degrees Celsius. You technically don't see the print PLA with a hot bed, but like it's better if you, and yeah, you don't have to prepare it as much. So usually we have 200 degrees for the filament and 60 degrees for the bed. But yes, the reason we have a heated bed is when filament is extruded, right? The heated bed makes it, one, makes it easier to stick to the bed, and two, when the plastic cools, right, it can shrink, and when it shrinks, it can warp and then pop off the bed. So imagine if you have a piece that the bottom is cool because it's being cooled for a while, and the top is still hot because it's being pressure extruded. One side is going to cool faster than the other, the bottom is going to shrink, and it's going to warp upwards, and the edges will lift off. And then we just come off and like it will be a disaster. So having a heated bed is important, especially if you want to print ABS, but yeah, there's no toxic fumes, so you don't really want to do that. A higher temperature is actually good if you want to improve the adhesion between layers. Because the way that it works, we're going to go think of layer by layer. Having a hotter temperature will make the filament layers stick to each other better. But the issue with hotter temperatures is that it will have more trouble doing bridges. Because hotter temperatures will cause it to drip more. So as I was answering your question before, when you bridge, it will make it drip a bit more. So if you're making anything with overhangs or basic features. You want to find a balance between having a temperature that's hot enough to basically have the sticking to each other well, but also cold enough so that it will bridge well. You can get away with it without a stronger cooling factor. Layer height. So the layer height is basically like our resolution of your printer. 0.2 is usually a good idea to go with because it gives. Guys, be quiet. Shut up. Yes. So layer height is basically. Yes. Layer height is like the resolution of the print, and 0.2 is usually a good idea to go with. The higher the layer height, the faster it will print, but the worse it will look. It's pretty simple. Infill is how much material that's on the inside. Because when we 3D print, right, we didn't really want to have a something that's exactly solid because it would take a lot of material. For the strength, for something to be strong, right? Most of the strength of the object comes from this surface layer, and then on the inside, that's going to be less that's affecting its strength. So usually we hollow on the inside, make it semi-hollow with like some sort of infill pressure. I don't really have the infill pressures out here. It would be nice if I can show you. Well, like there's a bunch of them, but we can adjust the as you can see here, we can adjust the well not there over here. You can adjust the amount of material compared to air that's on the inside of the print, and basically increasing that means the lines that make the infill are going to be more dense, and increasing that will make it less dense. And usually 15% is already plenty, 20% is more than what you usually go with. For static prints, you can either go from 0 to 10%, but if you want to make it strong, you can go up to 20-30%. And well, if sometimes you might be able to go 100%, but if you go to 100% refill, then maybe some other manufacturing method might be more appropriate. And wall thickness, because when I was talking about infill, right, that it makes sense that the 3D print is going to have an outer wall which is solid, and like an inner in the inner material which is not really fully filled in, but like with a pattern. The wall thickness you will determine how many layers the printer will go around to make the outside layer. Usually 2 layers is enough because if we have a 0.4 millimeter wide diameter extruder on the printed, then we'll have a 0.8 millimeter wall thickness. So you can go with 3 layers, which will make 1.2 mils, but 2 to 3 layers is usually a good idea. And for supports, so when I was talking about like overhangs and bridges, right? Sometimes you need to do like a 90-degree overhang or something similar. And something like that will be very difficult to print with in the air because it's going to start drooping, and all the filaments and the thing's going to droop, and it might even cause a failure. What we can do is we can check the generate support option, and that will generate like waste material that builds up in like a low density pattern, and that will create like something to hold up the overhanging part, or for really long bridges that will help too. There's a bunch of support types such as normal supports, which is just perpendicular to build plate, or there's even this thing called a tree support, which is quite fancy and you can just mess around with it yourself. And tree support takes a long time to generate, but it looks nice and can even save material. And finally, adhesion. So there are a few things that the slicer can do to improve the ability for the print to stick to the bed, such as I think a skirt is just a line, a ring around it. The main purpose of a skirt is to clear the nozzle. So when you actually start printing the thing, the nozzle will be primarily. A brim will actually basically have like I don't know. A brim is like an outer surface on the base of the model, so it increases the surface areas that's sticking to it, and it's easily removable. And a rough is like basically the be-all end-all. Like if it keeps coming up, then a rough will do the job. It's like a brim, but like it's quite big and there's a few layers thick. And basically your model goes on top of the rough. And with modern printers, you usually don't need to do that unless the model is really sus. Yeah. We can move on. And so when we actually print, there's a few options we can do. Let's say in Cura, we have the option to save the file to usually to a removable drive, such as a USB or an SD card. Because most printers use an SD card to print. You just put the file on the card and just plug it in and just use the printer or anything to slide and print it off the file of the SD card. And you can also connect the printer to your computer through USB, and QR will handle that. And there are some even more advanced options which I'm not too familiar with, such as using programs like AutoPrint to connect your printer to the web. You might need a Raspberry Pi to do that. Connect the Pi to the printer, install to print that, and so on. I will not go through that today. But yeah, that's basically it. Does anyone have any questions regarding that?
Yeah, I still don't understand what the brain or rock thing, like how it actually helps.
Can we go grab some pictures of a bird? I should have included pictures of that, but I will do that. So this is what the bird is. It's like a couple of like alternate pictures on the face of the thing. So as you can see, the surface area of the thing is increased, so it can stick to the better. Furthermore, because the brim is only one layer thick, but even without a heated beverage, when it cools, it can't really retract anywhere because it's only a layer thick, so there's not much force to pull it up. So it's basically like a huge suction cup. You just stick the thing down. And around just like that, but yeah, you can imagine like just a big chunky piece of plastic that's really flat and it sticks to the thing, and your print goes on top of that. So that's what a type of is. Okay. Does anyone have any other questions?
I just want to add real quick. If you have any issues with laser cutting 3D printing, just go ask Makerspace staff. They're like really helpful, and they'll just let you know what to fix or how to fix it. Especially with 3D printing, just as long as you have an STL file, you can just give it in, and she'll just get most of it done for you.
Yeah, what you said, like the Makerspace stuff that will basically actually do everything for you if you print. So like you don't even actually technically need to know. It's really good to know because like if you want to get a 3D printer, which is a really good idea, it's like, you know, it's basically like magic. Or like not magic. So it's really good to know how to do it yourself, or like if you're doing it at school, you didn't really need to, but school will do it for you. But yeah. Also just to add, like printing at a Makerspace if it's for a school-related project, then it will be free, but if it's personal, then it will be $3 an hour, which is quite expensive if, let's say, you're doing a 24-hour print, which costs like $1 for me in filaments money, but it only costs, if I was going to print at school, no, that was $3 actually, $3 in filaments cost, but if you print at school 24 times 3 would be, yeah, a bit of money.
Okay, so that's the end of our formal presentation. It is still 7 p.m., so feel free to start on your SolidWorks and CAD designs, and then we can help around as well if you guys have more questions. We also have Subway at the back, but no one stand up. We're gonna bring Subway around to you guys. Everyone doesn't like take like whatever they want. So yeah, hang out.
What part of Britain are you